Good evening and welcome to Urban Toronto Beekeepers Association. Today is May 2nd, 2023. We're going to start with the beekeeping calendar with Marion Whittam.
Thank you, Elaine. Okay. Thank you and good evening. As we gather members of the UTBA in Toronto, let us take a moment to acknowledge the lands. It has been a site at Toronto of human activity for thousands of years. It is still the home of the many Indigenous people across Turtle Island, the ancestral name of this island, and we are grateful to be able to live and work on this land. And this is the Toronto acknowledgement that I'm showing currently. A word about our beekeepers calendar. It is available to everyone online through our UTBA website. It's a lovely calendar, 24 colored pages, lots of information for you. It can be downloaded easily, or if you're at the meeting, you can pick up a copy there for free. When I teach this beekeeper's calendar, I just wanted to let you know that sort of my history. I am a small hobbyist beekeeper, and I used to teach the Bee Educated class for UTBA, but now I'm doing this calendar. And I'm also the interim chair of the UTBA and a member of the OBA, and both of those have been for the last 8 years. When I do teach, I give education references for you to be able to look at. And this meeting is being recorded and it will be posted the YouTube on our website in a few days. So please feel free to go ahead and to use any of the information it has. Other resources that I use, these hard copy books, which is Dewey Caron's Honeybee Biology, a very standard kind of textbook, but wonderful information, Stories, Keeping Bees, and our tech transfer manuals. Other resources that you can use are the Honeybee Research Center at the University of Guelph, which has an amazing 80 videos approximately and resources. They're all free for beekeepers. So just to let you know, May is here, warmer weather's here. You may have already cleaned up your bee yard. You may, if you have posted your AMAFRA registration, you should do so on your hives so they know, on your bee yard, so they know who owns that bee yard. And inspecting the hives. It's very important to do some observations when you open the hives and also to take records of that. We talked about last month what we did if we opened a hive and it was totally dead, and some of the things you need to look at. This is another little part that you could use for what happens if the colony does not have a queen and there's no sign of disease. What do you do if you open it? You can shake off those bees into the frames into a healthy queen-right colony. If the colony is weak, but there's 1 or 2 frames of bees, again, no disease, you could try and find the queen and reduce the double to a single if you have that. Reposition the frames so that the food and the honey are close to the brood nest. Increase the population by shaking the nurse bees, workers found on the brood frames, from another strong colony, and leave the covers on to keep them nice and warm. If the colony has 3 to 5 frames and the queen is laying well, there's lots of eggs and larvae and capped brood, the hive should build up. You can reposition the frames a little bit so the food frames are located near the brood nest, and make sure that there are enough honey stores, and if not, with the temperatures as it is now, you should be able to start to feed 1-to-1 sugar syrup. If the colony has a queen and it's strong with 5 or more frames, then you can remove the entrance reducers now. Make sure the queen has enough space to lay. You don't want to crowd her. watch the colony expand, prepare to add supers. And you can add honey supers when that happens, when there's 7 of the 10 frames with eggs, larvae, and it's covered that way. Now, if you have strong colonies, remember that once you have strong colonies, you also have higher varroa mite levels. So mite monitoring is a priority for you. And you might think about monitoring mites monthly and recording the levels. There are various methods of monitoring mites. For example, there's an alcohol wash, sticky board, sugar roll, and mite treatment should be done if the mite level exceeds the acceptable threshold. You watch for the mite draft to determine the mite levels and if the treatments are required. Very important to always follow the manufacturer's safety precautions and instructions carefully when applying treatments. Mite levels, there's mite levels vary with the type of monitoring you do, but here's an example. The OBA says the typical mite threshold in May is about 2 mites per 100 bees, and so six in 300, and 3 in the August timeframe for 100 bees. So the OBA, the Tech Transfer Center, has a wonderful reference source on varroa mite sampling and monitoring infestation levels. And I strongly encourage you to take a look at that. It's on the web. May is also, I've seen on some of the Facebook sites that some people are saying almost that they think some of their hives may be getting ready to swarm. So you have to decide if you're what you want to do. If you want to capture a swarm, there's a video, take a look at a video. There's some videos from the University of Guelph on that, and determine if you're going to split the hives, that it may be necessary. Sorry, I've just lost something here. Can you hear me?
Yeah, we can hear you.
Sorry, I don't know what happened. Everything's just gone blank on my screen. I'm just not quite sure what went on, or just bear with us for a second. Try and connect. I apologize. Just restarting. Ellen, if you can hear me, I'm not sure what's happened, but I'm going to have to end
we
my
see your last slide, I think.
Do you? Yeah, I don't know what's happened to my computer, but I'm going to have to, we'll give it one more try here.
Yeah.
And see, I don't know what's going on, but I'm afraid I'm going to have to end it at that point. My apologies of that, but technical difficulties, as you know, do come, and I'll have to try and problem solve this. Thanks, everybody, and I'll be listening on board for everything else that I can hear. Okay, thank you.
Sorry. Yeah. Okay.
Marion, can you unshare your screen? Can you stop sharing? Yeah, you can go ahead and stop it. Yes. Yeah. Oh, and then close it. Don't share.
Also, Michelle, if you can mute everybody else.
No, we don't want to screen share. I thought we could close her, but we can't.
You could do it that.
Yeah, go ahead and share screen, and then
And stop sharing.
Yeah, and then stop sharing. Then press stop share, which is the red. Right. It's the center. Yep, chasing it. There we are. Okay. There we are. And I think he wants us to mute everybody. So can you go down to the bottom, bring up participants, and then mute all, and then Lynn will have to unmute himself. Okay. So don't forget to unmute. Yes. It's not very convenient. There, he's unmuted. Okay, we're good. And we need to mute ourselves.
Okay, so let's continue with the apiary of the month. Nicolle, you can share your screen. Also unmute yourself when you're ready.
All right,
Can you hear Lynn?
can you hear me?
Yeah, sounds good.
Okay. So my name's Nicolle, and I am a Toronto beekeeper. I keep bees on the roof of my house in Toronto with my son, Mika. And we are relatively new beekeepers. We've just had 2 years of experience being hobby beekeepers. We don't have any aspirations to be much more than hobby beekeepers. And so I wanted to present my hive a little bit for you today with humility, knowing that I'm speaking to people who have many years experience and have many, many hives. So I thought we'd talk a little bit about how we got started, where we keep our bees, and maybe a little bit about the highlights of our first 2 years. So that's my son Mika in the backyard with the smoker, getting ready to go up and visit our bees. And he's really what got me into beekeeping. I had been working at turning my yard into a bit of a urban farm for years. And so beekeeping was a good idea, I thought, when he brought it up. He originally was hoping to take a full-term course at Guelph, where he was in university at the time, as an elective to become a beekeeper, but it didn't work out. And so being that type of mom, I looked online and found that the Honeybee Institute offers 2-day workshops, sort of introductory workshops. And so we decided that we would take that on as kind of a project together. It's a thing I do with my kids. It's why I also can unicycle and juggle and play a little ukulele. So we had plans in 2020 to go up to Guelph and spend the weekend and learn all the basics of beekeeping. As you know, in 2020, there was a major event, and COVID shut down the course for that year. So our start to beekeeping was a little bit delayed. In 2021, they again were hoping to put it on, but couldn't, and decided instead to put the course on online. So they did a 2-day online course with through Zoom with videos and live presentation. And having caught myself on Zoom that year, I knew what was possible. And so we joined in and did our course that year with them. And it was really very helpful. And I have since spent a lot of time on looking at their videos and found them quite helpful. We, of course, also went and looked at all the other sources of information. So like many beekeepers, we were reading books, we were going online to YouTube and looking at websites, joined the UTBA, that sort of thing. I guess the one thing I would say as a new beekeeper was that it was fairly quickly very evident that you have to be careful online. There's a lot of information that's not that helpful for our context. And so I've really restricted myself to more local sources, really. This is a picture just to show the context in which we keep bees. So let me see if I can point to it. This little spot with the house on it here, that's our house in Midtown Toronto. And we live on a fairly small lot. It's, I think, 10 by 25 meters, something like that, the whole property. We have a small front pad garden, a backyard that looks onto an alleyway that's frequently used by bikers and dog walkers and neighborhood kids and whatnot. So that's our context in which we were thinking to keep our bees. So when we were figuring out where we would keep bees, I think the main things we thought about first were our neighbors. We wanted to make sure that we were being respectful to our neighbors and not going to be imposing on them in any way with our bees. We did let our immediate neighbors know prior to getting bees. We didn't want to find ourselves in a situation where we decided to take up beekeeping only to find that we were getting complaints in the neighborhood. And we received quite enthusiastically around that. And then family as well. So we have a small lot in the backyard. We use the back garden and yard for gardening, but also for visits with family. We often have family gatherings in the summer out there, and wanted to make sure that we weren't going to have any issues with the flight path of the bees or the use of the garden in other ways. And then also we were, I was a bit concerned about the laneway in the backyard. So at the time it had, our back property had an old fence that permitted people to see in from the laneway. And, you know, we're in an urban environment. We do have people that sometimes hop the fence. I personally had 4 plants that were cut and stolen from the backyard one year. They were interesting plants. But so we know that, you know, people look in, and I wouldn't want somebody coming in to the backyard in the night and disrupting the bees or, you know, having any encounters with them. So all of that led us to decide to put the bees up on our roof. We have an old house that has many different roof surfaces. It's one of those houses that was a small house and then built onto. And so we have a couple of flat or semi-flat areas that are fairly easily accessed. And that's the hive right after we set it up, after we got our nuke in our first year. We're running a single hive. It's a little higher because we were set up to feed the bees. And you can see there's a couple of wires there that were not active. They were dead wires that we eventually cut down and got out of our way. But we did ensure that they were dead before they were geese up on the roof. And there's a picture of the backyard looking towards the bees. And if you look, you can see we've got a ladder that is tied down to the house there. And then up at the top, you can just see the top of the 2 hives. That was after we had split our hive last year that they were up there. So we have the opportunity to see them. If you come from the front of the house, you can't see them at all. And from the laneway, you would really need to be looking very closely, maybe, you know, even looking to see them. So for us, the rooftop was a bit of an ideal sort of problem-solving solution. For one thing, the bees are out of the way of all the other activity that we have in the backyard. It's not a big backyard. It also affords a little bit of privacy in that the bees aren't easily seen when no one's up there. They also get full sun, or they did. Caveat that we have a new building beside us, but they get more sun than we could offer them anywhere else on the property. The challenges, I guess, some people might think the ease of access is a bit of an issue. We do climb up that ladder to get to the bees, but I don't think we've found that much of a difficulty. The ladder is securely there. It's easy to go up. We bring up what we need. Sometimes we leave a few things up there, but mostly we, you know, we bring the smoker down and all of that and just take it up when we go. The one thing I would say that was a bit of a downside to us to having the bees up on the roof, and I think this is particular to people such as ourselves who are really new beekeepers, is that we didn't have the opportunity to look out in the backyard and watch the hive in a daily way, as I think many newer beekeepers would, to see the flow and to see what the bees are doing and to really learn from the coming and going of the bees. We could stand at the back of the yard and just see bees coming in and out, but not clearly. And we could only really watch them closely when we were up on the roof, and we weren't up there every day, although we were going up. You know, we do go up every week or 10 days. And then the only other thing is that while it's private, one of the things we quickly realized is, you know, if you get a smoker and put on a bee hat and go up on top of the roof, the sight lines are visible, both to the people on the other side of the alley, people in the alley, and neighbors about 2 down. And I remember one day being up there and seeing my neighbor 2 over, like with his camera taking pictures of me. Fortunately, I think he was just doing it because he thought it was cool. And we have since spoken to him quite a bit about bees, so they're up for it. Just a little bit about our adventures with bees. I guess for us, our big motto for the first year was don't kill the bees. So we were trying really not to have high expectations for honey and all sorts of other things, but really to see the first year as a learning experience and hopefully learning to manage and take care of the bees in the way such that, you know, when we came around to the next year, we would still have bees. And I'm happy to say that was successful. We fairly quickly felt quite comfortable inspecting the hive, going into the hive and going through it. We worked to learn how to do kind of purposeful inspections, sort of have a plan for what we were looking for, and to respond to conditions in the hive, and to really not just have the hive, but be managing the hive, really. And I come from a healthcare background, so the idea of having a plan, knowing what one expects, going in and making observations, coming to an assessment, making a new plan, and being responsive is for me part of what I do in other parts of my world, and part of what I really liked about beekeeping. And I find both challenging and kind of fun. We also had all sorts of adventures with record keeping. I think it's really important to keep good records, and particularly as a new beekeeper, I found myself really wanting to take a lot of notes because so much was new, and we were really learning how to observe and what to observe. So we went through various methods of record keeping. At first, I think I had a little black book that I wrote things in, and we would do our hive inspections together, Meek and I, and so we would take a camera and take shots of the frames to look at afterwards. We tried videotaping. That wasn't for us. Eventually, I moved to using Aline, your tick sheet that you had given me a copy of at the store. And now I do kind of a combo of that and an online journal. So I try to kind of use that to reflect, and I can look back and see where things are at. And that's been helpful to me. The biggest challenges in our first year, the first was that we missed a swarm in July. So, you know, we got through the early part of the season online. Everyone was talking about that year of many, many, many swarms. And we went away for 10 days. Before we left, we did a sugar shake to check for our varroa. And being new beekeepers, it didn't really occur to us that we needed to do a really good hive inspection and then do the sugar shake. So we were in the hive, we found our queen, we got all excited, we did our sugar shake, and then the bees were, of course, in no mood for us to continue our inspection. And that was just prior to us leaving to go to a cottage. And so when we came back, we opened the hive to find no queen, no eggs, no young brood, you know, that typical sort of really open center of all the hives. But being new beekeepers, we of course second guessed ourselves and thought, you know, is it possible that, you know, we're really just not seeing what we're seeing? So we actually called a more senior beekeeper who graciously came and asked us to do a hive inspection with her present. So rather than doing it themselves, you know, had us do it, which I thought was a really nice way of supporting us. And she gave us, you know, feedback on what we were doing, but she also confirmed and spotted a virgin queen in there. So we had a bit of a discussion about management at that point. Should we let this virgin queen go on their flight and come back and hopefully have a new queen that way? Or might we want to do what some people do, which is to buy a new queen and and go that way. And we opted to leave the hive and see if the queen would successfully mate. So we stepped away from the hive, gave her a little bit of time, came back, and sure enough, she was back. We spotted her. There were eggs, and we went on our merry way. So we were pretty excited about that as first-year beekeepers that happened. Sad that we missed the swarm though, and I can tell you I'm a little bit more on that now. I think, you know, like many things, you learn from your mistakes, right? And then the other big challenge, and it's been a challenge throughout for me, has been the wasps. So we have lots of wasps in and around our property, and the yellow jackets are just really fierce around the hive, particularly towards the second half of the summer, and make it difficult to do hive inspections. There's always, you know, flying around the floor of the roof where we are, maybe 10, maybe 20 wasps at a time. And you open up a frame and immediately 2-4 wasps hop right on there and they're right in. So it means that in the latter part of the year, I was doing rather quick hive inspections, trying not to overstress the bees by opening them out. I put up 1 million wasp traps, and you know, they were successful to some extent and not to others. But we did end out our season well. We didn't have any honey, but this hive was really strong. We didn't need to do any treatments, but we were monitoring for Varroa throughout. And then year 2, we came back and the hive looked really good. My son was away the second summer, so I was doing solo beekeeping that summer, and managed fine. I mean, I think it's interesting how having a second pair of hands makes things easier. So there were less pictures, I guess, from year 2 is what I would say. I did switch from doing sugar shakes to doing bottom board checks for the Varroa. And I think for me, for now anyways, that's working well. We did end up seeing the Varroa count move up. And so we did treat for Varroa. And I was grateful both for the information from the sessions here, but also the Ontario Bee Association Integrated Pest Management book, which really helped walk through in a really clear way and made me feel quite confident. And Lynn, I think I might have relied on you as well at the store to give me some advice around that. So thank you for that. As you can see, we did again find ourselves with a potential swarm happening. So the message I'm getting is that I shouldn't go away, because again, we go away for 1 week of summer. I went away for that week, came back, looked in the hive, and there was at least 5 queen cells in the hive. And so what I decided to do was to split the hive and mimic a swarm. So the queen went with some of the bees, some cap brood and honey in some frames in a new hive, and the other hive was left with the queen cells to hopefully grow a new queen. That was actually successful in the end, and we ended up with 2 hives. So that's our setup after we had put them in. And both queens were present after a short while and laying eggs. So that's all exciting. You can see one of our little wasp things up there. We did find though that second hive didn't grow as fast as we might have thought. And at the end of the season, so that was a late, was it a late? I think it was later in the season. By the end of the season, it was still quite a small and weak hive. And so we sought advice, I think, here and online, and we're considering either integrating the 2 back into 1 hive, or maybe just seeing if I put it in a nuke box, so it wouldn't be in such a large container that it couldn't manage the heat. Could that hive survive the winter? And that's them wrapped up. You can see we did decide to put it in a little nuke box. Unfortunately, it didn't survive the winter. The hive 1, our main hive, is fine, and seems to be doing well, but the first one, the nuke, we did lose. I think it probably didn't get too far into the fall because there was still a lot of honey. We had put a patty on top and that hadn't been touched at all. So there wasn't, I couldn't find any signs of anything else. I did note though that in reflection, I had tested the 2 hives for Varroa, and we had treated hive 1, but we hadn't treated hive 2 because the levels weren't high enough. And I wonder in retrospect if I might have done that, if it might have made a difference. So here we are in year 3. We're back to our 1 hive, and I'm still managing mostly on my own. My son's, he was in, where was he? Most recently, he was out by Orangeville. Now he's going to Collingwood and comes around and helps when he can. But I'm mostly keeping the bees on my own. In terms of kind of my anticipation for this year, ever the Toronto scene, the nice bungalow that used to be beside us has recently been a construction zone and is now 3 stories high. So right now the bees are getting a lot of shade. We're also doing a small bit of renovation on the back of our house. And so that's meant disruption as well. And I've moved the bees over winter a little bit so that they wouldn't be too close when the contractors are up on our roof because they're doing some work up there. But when our work is done, we're planning for a rooftop garden on the new part of the house, and the bees will move over to that side and be sunny. But that won't likely be till next year. So I think this year is another year of just not killing the bees and trying to manage as best can with the situation, because really we've got our backyard's a construction zone, the neighbor's backyard's a construction zone, so there's a lot going on there. And that's my hive. Question, how do you get the honey frames down? You just carry them.
Yeah.
A whole box? Well, you
One time at a time.
can carry them in a box. I forget if we passed them down or if we took them one at a time, but you can do both. And you know, my son's 23, right? Like he's a strapping young man, so I mostly do the heavy lifting stuff when he's around. But also, I have to say, we didn't get much honey, so it wasn't about taking a whole, you know, a big thing. We had a few hives. I mean, Michelle can testify because she's spun them. There was just a few frames that had honey in it, so it wasn't so bad. But yeah, I thought about that. If worse comes to worse, we can go in the skylight. So we do. We have a skylight up there. We'll make do.
I have a question. When you split your hive, sometimes they recommend when you're splitting to move them to a different location so the queen doesn't go back to her old hive. What did you do?
We did not.
And it was fine.
And it was fine.
Fantastic.
Yeah. I mean, part of it is we really are just on this little roof in this little plot in the city. So, you know, we're going to do what we can do is really the truth of it. Yeah.
Can you just talk a little bit about wasps? Like what do they do?
They are wicked. They attack the bees. They'll eat the bees. They try to take, like they'll catch them and eat them while they're flying. They'll go for the honey. They try to get in the hive wherever they can. So they're constantly sort of trying to get in the cracks and the crevices, and they'll try to go in the front door. And when you see the bees go out, like literally there are, in my place, there's like 10 wasps flying around sort of trying to catch. If ever there's a dead bee, they're eating it. Yeah. And then if I pull out the hive, they go straight for the honey and the bees. So they, like if you pull out a frame, they're on it immediately.
We had back home, we had like 6 hives, and one hive got absolutely assaulted by wasps, and you would see they ripped off their heads. Yeah, so you'd just see their little bodies.
Really?
Yes. And they were like really low to the ground, like she was saying. You'd pull out, and they'd kind of fly up from your feet and attack the frames. They were
I mean,
like,
I've never liked yellow jackets, but now I have.
Now I
been
hate
falling
them.
for them.
Not know this.
Yeah.
What's next, Elaine? Are you?
I have one question, Nicolle. When you will move them to the new location, will they get more sun than the current?
Yeah. Yeah, the challenge now is because I don't know if you could see in the pictures, but literally our houses are this far apart.
Mhm.
So there's like, 6 inches between the two houses, and where they are, there's now, a 3-story house where they used to get lots of sun. So we're gonna move them to the other side of our house where, the shade will.
Yeah.
So they'll for sure get more sun. We'll put them right at the other side near our other neighbor who's thrilled with the bees anyways, so she'll be happy to have them close to her.
And will you have the same easy access to climb up to them and so?
A little bit different. So the back of the house, when we had it built, when we had the ladder up, there's kind of 2 planes. And so the bees are at one flat level and there's a lower sloped, very slightly sloped. So you could walk up the ladder and hop off the ladder and then hop up. Now it's just a straight ladder. And in all honesty, I'm waiting for the construction and figuring out what I'm going to build to access. So I'm thinking of building something, building a small porch. And haven't designed yet the stairway to go up.
And in terms of treatment, what treatments did you use?
Formic Pro, I think.
So you did only one treatment a year?
We did one and the counts were good afterwards. Should I have done more? I'm happy to hear if you think otherwise.
Well, no, if the counts were good after, then you're fine.
Yeah. No, we did one and I was quite impressed. So it was my first time treating, pulling out that bottom board and seeing those mites.
Okay. Did you take a picture of that?
No, I should have, but I did not, I don't think. Yeah.
Oh, that's your homework for next time.
I need to take more pictures.
All right. Thank you very much. Very interesting. Hopefully we'll get more urban beekeepers. Sorry, was there another question?
Yeah, this one about the city bylaws and things like that. Like, did you approach it at all? Or
Well, we did look into it. So, there's nothing with regards to the city. Beekeeping is covered by by the Beekeeping Act in the province. So there's nothing that says that you can't keep bees in the city. But the Beekeeping Act does say that in order to keep bees, you have to have them 30 meters away from the property line and 10 meters away from any highway. So we're definitely 10 meters away from a highway, but we're not actually able to be 30 meters away from our property line, nor are most people in Toronto. When we started thinking about keeping bees, we asked around, and my understanding is that, I still am registered with a MAFRA. MAFRA knows where my bees are. There's not an active attempt to stop people from beekeeping in Toronto, but if you get complaints, they will ask you to move the bees. And so that's why I think in the city, for us anyways, it was really important to talk to our neighbors. And anyways, so who wants your neighbors being mad at you, right? So
you give them honey, but so did you talk to like 2 houses down, 3 houses down, or the immediate house?
I think we went 2 on either side.
Yes.
And then the word's gotten out, like the neighbors know, and so we've given honey to people and we talk about it. And we've tried over the years to cultivate good relations. So our neighbors come and take our rhubarb, the little kids come and grab the raspberries. So I think we're lucky so far.
Okay.
One thing I noticed was you don't keep water up there for them.
No, we have water on the yard for them. So we had started, I did have water up right beside them, and they didn't seem to pay any attention to it. So then I put water in the front and the backyard, and they go to that. Yeah.
All right, we're gonna continue with the B-Frames Canada Limited presentation.
We'll have to introduce yourself. Fresh presentation.
Thank you.
Beekeeper?
Yeah.
Come on in. Come on in. Okay.
So my name is Ivailo Boutros. It's B-Frames Canada Limited. His owner is Jivko, myself, and this is our family. And we're here to show you our products and what we make. Strictly manufacture bee frames, only 2 sizes, no other thing to manufacture. We don't do heights, and it's nothing else. It's frames, the 2 sizes, the medium and the deep. Okay, so currently we make them with, they come in 3 colors, which we can offer you, the white, the yellow, and the black. And they're from the Canacell product, which is wax covered. And the actual material is white pine. And each one, we have looked at the market and we have seen what's offered. Gifco comes from manufacturing these for 20 years. Okay. It's a family business, this is why. And we have been doing this and we've seen the market, what they sell. And the first thing which came to his head is, why don't we make it here? Okay, they were the biggest exporter to France. Over 1.5 million frames per year, we used to sell just to France. And the quality which we found locally, and we did an extensive markets research, we could not find what these ones which we made. Okay, and the pricing is outrageous because for you to have a product, you need to have. They fall apart. They don't maintain they're not rigid, and this you won't find. So each one of these have 8 staples. The best we have seen are 4 staples. Okay, they're 8 staples and they're glued. The glue is obviously made for honey. So each corner, you will have some samples before we leave. Okay, we're not here to make profits from delivery, from stuff, but we are trying to deliver to everyone free of charge. Okay, if somebody wants 5 frames in Muskoka, we'll give it. Please. I'm not sure where's the camera pointing at.
Well, put more on. Do gallery and look at and find us. There we are. All right, so that is a white plastic foundation on a medium. Yeah, there's a D. This is a yellow plastic foundation on another medium and smell very nice. And this is a deep black plastic foundation. Easy to see your eggs. Yeah, and we can pass them around here. They,
Yeah, where are they made?
oh, where are they made? They're made in Canada, right?
Everything is locally made.
Oh,
Everything.
we're in Canada.
Oh, here. Is there any, is there a website? Okay. And your website?
Yes, we have websites at the end of the presentation.
Okay, so in the presentation, Tom,
Yes.
pass them around. Let people take a look at them. Thanks, Mom. Yeah, no, you're good. You finish speaking.
According to our European clients, we don't get involved in that, but there is about 30% more honey produced when it's wooden frames versus plastic frames. Okay, I won't go into that, just give you the information we have. So with our extensive search, with our market research, this is the best price we could have found. We have not seen these prices here. Okay, and $3.80 are the deep. $3.90 of the deep, the medium are $3.80 per frame. We're not in the business of delivery, as we said. Let's say it's 100 frames, 50, 100 frames minimum. If it's within the GTA or around the GTA, we will deliver with our own cars. We don't want to ship. We want to cut the cost for everyone. And these will be there for you for a few years. Nothing will happen to them. Nobody puts the staples here on this end. Nobody puts them here, and that's where they fall apart. There's 20 years experience, done a lot. We still exist, and we're here.
And where in the GTA for pickup? Where in the GTA?
We'll bring it to your house. We'll bring it to your
No, but if our
place.
delivery is smaller, our order is smaller, we can pick it up from
I can
you.
meet you anywhere in the GTA. We're still, we don't have a manufacturing. We're working on a big place, okay? the way used to do it, Jivko, he used to do from the lumber, from the action, from the trunk, from a tree, cut it, shave it, make it, frame it, and sell. We do the whole thing. Just all the kind of machinery. Okay, so this is what we do. Bframes.ca is our website. It works, but it's not complete. It doesn't have pricing, doesn't have anything yet.
We need to just
By
get
the end of the week, we should have it ready. It's not in our hands. That's my email. info@bframes is your best thing to find information. And if it's a small order, especially, info@bframes.ca will give you exactly what we can do. We're here to help you. We don't want to make money from delivery. If it's something small, we'll tell you, well, we need $30 for gas. The order is so small, we need to pay for it.
It's also possible that if we have a whole bunch of little tiny deliveries, that you just coordinate and have them come meet us at our June meeting, and then he'll bring them to the June meeting, and then everybody can.
We
pick up
have
their
no
stuff.
problem.
That's what
Let
we
us
think.
know. We're here to work with you and help you.
And do you sell replacement comb?
Да продаваме само вътрешни.
Did you mean to say?
Yeah.
You sell the foundation?
We don't sell them because we only sell frames and the two sides.
Okay.
This is
So you have to
all.
pick up your-
Okay.
We don't want to enter into, maybe in the future, but at the moment, these two size frames, and that's
Okay.
what.
Yeah, that's great. That's great.
Tell me, is there any functional difference between the colors of the frames,
This is your preference. We've seen lots of people which will swear by the black because they don't see very well. They can see better. Some people like the yellow because it's natural. Some people like the white. It depends.
so it's just aesthetic preference, there's no
Yes,
functional?
preference, yes. They're the-
The only thing is the functional of if you have the black where your brood is, you're more likely
You
to
can
see
see,
the eggs. Yeah, for some of us, it's hard to see the eggs on the yellow or the white.
I wear my contacts and I see very well, but if I don't wear them,
Yeah.
the black won't help me either, so. These are for you to keep. I hope everyone has one. And,
Thanks very
the
much.
best thing you can do for us is tell your friends, your families, and, we want to join every meeting. we have,
Okay,
because we can.
no problem.
Okay? That's it.
We'll be here next June. We'll be here next month, and then after that, we take a break until September. We'll have some picnics in the summer, and if you just join as a member, then you'll get all the information. $25 a year. Join as a member, and you'll know where we're gonna be.
You can share that info with me. Can you give some cards around?
Absolutely. You need a 5-minute break or anything? Are we all good? All good? I'm just gonna get some water.
Excellent.
Just to sell, I asked earlier, right now, it's just to sell directly to us, Tom.
I have one.
Thanks, Michelle.
Okay. Yeah, I already asked that question.
Thank you for the frame.
Share.
All right.
You on a break? Me breaking?
People said they wanted.
I brought some honey samples. I've been meaning to show them off last year. I have some honey samples to try from Sicily. And I think I have one from Greece. And I have from Spain from my last travel. And Ireland.
Ireland, oh.
Sticks. Depending
Depending
on how many you travel. Yeah, I go visit years.
No, that's right. I'm putting on my jeans.
I was in Crete last winter, so not this winter. This winter, the past I was in South America and I brought some samples. So I'm just gonna start beekeeping in Toronto. That's my meeting with guys. So I don't know how many we are. One, two.
Because if I can order, like I'll order direct to you, but then you can ship it, like across Canada. But it's going to BC. British Columbia.
I think the trick for not to
Like,
double.
okay, okay, yeah.
Everybody gets to do. Yeah.
I want to see you this. So I'm gonna deliver it for you for no charge. Just, we want to make it for you simple as
I'll
possible.
line them up so that it makes
You
sense.
can ship it for us because we
So.
we're a company. We can ship it any price. They're gonna be more expensive. The best thing is you take it from us here, no charge. Okay, anywhere in the city. We give it to you.
Yeah.
Thank you.
I'm just gonna sit here.
Hope you like it.
And then people can come
Yeah.
around.
Destiny, when are you moving into your?
Hopefully July. Yeah, it was supposed to be last, you know,
Yeah, it was
Sure did. I
nice.
taped them.
and then it was supposed to be May. And then they delayed it just now again until July, which like I think working out better.
Yeah. like, okay.
But we're excited. And I was, yeah, I couldn't find any information about beekeeping in the city. We're not actually, but I know that like the Shangri-La hotel downtown, and there's another hotel too, that they have bees on their.
Oh.
All right.
UT has
Are
it.
we
I
ready
worked-
to move on?
I work at
Oh,
a metropolitan university. We have bees on our roof. So the number of places.
There's some
I did
smaller
dynamic
libraries
sense.
that have bees on the roof. I know Milton actually has like a whole like
whole thing going on.
industrial setup. So I'm hoping that like that would be, I'm hoping to get on my condo board and then get myself access to the roof and then beekeep off the roof.
Yeah.
I would love to do that. I would love to have that.
Thank you, everyone.
Thank you.
Hope I see you again. Next meeting.
Thank you.
Excellent. Thank you so much.
Thanks, guys. But yeah, I'm hoping, yeah, I can, and then, and, you know, if they participate in the hive, they can keep the honey or whatever, like make it a like community. Yes. I definitely, that's something I miss from BC is having like a sense of community. So I'm hoping that that, because I love bees. I'm hoping that that'll be something for me. But I love it.
Into getting to know your neighbors.
But I love your setup.
Yeah, so far it's worked well.
Yeah.
You know, so I don't know if I had.
The people at home cannot join in this impromptu honey tasting that is happening at the back of the room. Sorry for you.
I let people know it was happening last time. In the last meeting, we had a sampling as well.
No, we'll, yeah, no, I'd love to try some. I'm just gonna wait till after our speaker and then I'm gonna head back. So if you do want our featured speaker, Lynn, I can do I'll go back and taste the honey at the end.
Okay, so are we ready to move on?
Yes, everybody's ready. They'll take seats. We all wanna
Okay,
hear Paul.
so tonight's keynote speaker is Paul Slayton. He is a Cornell-certified Master Beekeeper. He recently moved to from New York to Florida. He maintains colonies in central New York for honey and milk production as well as small-scale pollination. He founded the Northern Dutchess Beekeepers Club in Rhinebeck, New York, and is a member of the Mid York Beekeepers Association in central New York. Now he's learning to keep bees in a tropical environment, USDA hardiness zone 10A, as a member of the Beekeepers Association of Southwest Florida. Paul?
Lynn, thank you. Just can you hear me clearly?
Yep.
Very
Yep.
good. Thank you, Michelle Wolfson, for inviting me to speak to the group tonight. It's springtime, drones are in the air, and I'm excited to talk to you about drone congregation areas. So let me share my screen. Where is it? Here we go. So let me put it in full screen mode for you. Ah, yes. All right. You see the full screen?
Yeah, it looks well.
Awesome. Very good. So I created this talk as part of my studies in the Cornell Master Beekeeper program in 2021. And it's a topic where research is changing the way we understand some key long-held facts, but there are many mysteries that still exist. So let's dive in. Just a little bit about me. As Lynn said in the introduction, I keep bees in central New York, in Oneida. A lot of goldenrod, honey. The flow starts in late May and mid-May and runs through September. So constant flow, never a dearth. I started beekeeping in Rhinebeck, New York, in the Hudson Valley. Lighter honey from clover. Sometimes we get black locust. It's awesome. One time we had a farm field of white mustard, probably 80 acres of white mustard next to my colonies, and all that honey came out with a little bit of a tang to it. So all beekeeping is local and depends on the soil. I think for every speaker that you don't know well, it's important to understand where they come from. So my influencers, people that shaped how I think about beekeeping. In the upper right, Dr. Tom Seeley wrote Honeybee Democracy. It was the first book I read, and his newest book, one of his newest books, The Lives of Bees, is really spectacular. In the middle right, that's Randy Oliver from Scientific Beekeeping. I love his constant experimentation and holding fast to the scientific method. The couple in the center there, Yorick Phillips and Megan Denver, Hudson Valley Bee Supply, really got me started as a newbie. Lower left, Michael Palmer from French Hill Apiaries in Vermont. His whole concept of sustainable apiary, I think, really influences how I think about what I want to do in my own apiary. And then the crazy guy in the upper left is probably, hopefully some of you know, Sam Comfort from Anarchy Apiaries. And I got to meet Sam and work with Sam, and his experimentation leading to the Comfort Hive, I think, is really awesome way to keep bees. And then, of course, all the writers that write in the American Bee Journal and Bee Culture magazine every week. You got to read them, kind of keep up with the field, right? Oops. So, what are we going to talk about tonight? We're going to talk about drone congregation areas, and I'm going to do a little setup with drone development, physiology, behavior. We'll talk about why they matter and the importance of genetics. We'll talk about the mating behavior itself, how that happens. So that's kind of the birds and the bees part of the talk. And then we'll talk about research pioneers. How do we know what we know? The technology they used. And then we'll kind of sum it up with, well, what are the facts? What are the things that we think we really know with certainty about drone congregation areas? And what are the mysteries? What's left undone? And then there's some, of course, new news. And then taking a page from Randy Oliver, I want to wrap it up with practical application. What should you know as either a hobbyist beekeeper, maybe a sideliner? What are the practical applications for you? Make sense? Awesome. Let's get going. So, what is a drone congregation area? So I want to start with this model, start tonight's talk, and have this model in your head, this conceptual drawing. So a drone congregation area is simply a place where many drones congregate high in the air to wait for a virgin queen who's on her mating flight. That's what it is. But let me do a little setup for the mysteries part. So, but why? Why do honeybees use DCAs as a mating area? Because that kind of reliance on a defined mating area is not common among higher animals. So here's a few hypotheses to think about. First, well, maybe high drone numbers, like 10,000 drone numbers in a DCA, could be the consequence of selective pressures, right? Because colony health is queen vigor, it's all dependent on queen mating with 12 or more drone suitors. So maybe it's just we need high numbers. Second hypothesis, maybe the use of the DCA reduces the environmental risk for the queen, right? So she's only got to go one spot, doesn't have to fly around, get hit by a bus, get eaten by a bird. Maybe the third reason for DCA allows the queen to select her sexual partners, right? The most fit males to mate with, right? Because they're all there. So the queen gets to pick. So you may have other ideas. So there's three things I'll throw out right away. So as beekeepers, we know a lot about the three casts, and we know a lot about our queen, right? The size, the color, the race, the performance, the age. We talk about queens all the time. And we worry a lot about workers, both the population size, their growth, whether they're building up, the health, whether they're infected by this, that, or the other disease. But what do we really know about drones, right? What do we know about drones? So as a refresher, how do you tell the three kind of casts apart? So queens have a large black thorax. Hopefully you guys are starting to mark queens. That's a good thing to do. And once mated, the abdomen extends past the tips of her wings. That's the other way to tell. Now workers are small. Everybody knows what a worker is, right? Smaller than both queens and drones. Their wing tips do extend past the end of their abdomen. Their thorax is usually hairy, and the eyes are not a dominant feature. And then the drones, well, drones are larger than the workers, more barrel-chested, barrel abdomen size than the queen. And they have fuzzy, hairy, and rounded abdomen tips. So you can see the hair sticking out of the back of the abdomens. And drones have really big eyes, right? Okay, so those are the three casts, a little bit about drones. So what's the life of a drone like? So drones lead very different life than other bees, both in their development, which I'll show about on the left side, and in their life as adult on the right side. Because they're physically bigger, they get raised in larger cells, 6.4 millimeters typically than the 5.2 or 5.4 or 4.9, somewhere around there size for the workers. We can debate that, but drones are in the bigger cells. They're fed less royal jelly than the queens, but a lot more than the workers get. And they spend one more day in the larval stage and 2 more days in the pupal stages. So that's key. So they take 3 days longer than a worker bee to emerge eventually on day 24. Now, looking at the right side, as an adult, the drone's life is shorter than the worker. It's much different than the worker bee. So first of all, drones need extra attention from the workers as they emerge. They stay in the warm brood area and have to get fed by the workers for the first week. Around day 8, they'll perform a cleansing flight, and then they migrate away from the brood area and kind of hang out on the honeycombs where they begin to feed themselves. Day 12, that's a key day for them. They're sexually mature and they can begin mating flights. And those mating flights last about 25 minutes each. So drone lives are short. They live 3 to 5 weeks. And during this time, they'll fly to DCAs whenever the conditions are optimal for mating flights. So mid to late afternoon, warm temperatures above 64 degrees Fahrenheit. Pardon me, you guys have to convert to Celsius, but above 64, 65, and on sunny or maybe partly cloudy days. So my wife likes to say drones basically hang out on the couch and then they go to the singles bar whenever it feels like, right? So that's basically what drones do. That's their life. Now drones are specialized, and they're very specialized for their singular task, which is mating with a virgin queen and passing on their genetic information. So on the left are 5 anatomical differences with workers, right, that enhance their ability to mate. So first, their antennae are longer and they have an whole additional segment and more olfactory plates, so they can smell the queen pheromone. The eyes are much larger, almost meeting at the top of the head, and the optic lobe in their brain is bigger to process all that visual stimuli and be able to identify queens in open flight. The flight muscles are stronger and the wings are broader so that they can be able to catch up with and mate with a queen in midair. And the drone is heavier than the worker bee because he's got to fly around all that reproductive junk. And they fly faster than the queen, up to 35 kilometers an hour. So 50% faster than the queen. Now on the right are 5 anatomical parts that have been reduced or shed altogether through evolutionary pressures. So if these are things that worker bees have, but drones do not. So the proboscis is only half the length of the worker, since drones don't need to extract nectar from flowers. Their mandibles are smaller because they don't have to collect pollen and chew it. Gone are the wax, the naphthol scent glands, and the hypopharyngeal glands, which produce royal jelly. And those are underdeveloped. There's no pollen baskets on their hind legs because they never forage for pollen. And there's no stinger since the drones do not participate in colony defense. So the drones are special, as I like to say, in a special way, in many special ways. Okay. And certainly within a population of drones, the bigger, heavier drones carry more sperm, which is kind of their job. And so research has shown, strong correlation between drone weight and the amount of sperm that they carry. And we'll see in a moment why raising healthy, big, heavy drones is important. So let's talk a little bit about why DCAs and drones are important. Well, we know that colony survival is a function of a couple of things. It's a function of your queen vigor, it's a function of your worker population and its health, it's a function of the available food, and also the drones. But what about the drones? Well, you need lots of them because they provide genetic diversity. And well-bred colonies are larger, heavier, more likely to survive. Without genetic diversity, basically that comes with multiple drone matings, bees would have one mating and you'd have inbreeding. And bees would be like this frog who thinks he's a prince, right? So you need a lot of drones for mating, and that's what's important in genetic diversity. So a little historical context here. This guy, Dr. Johannes Dzierzon, Polish Roman Catholic priest, trained in theology in Germany, combined his theoretical and practical work in apiculture with his duties as a priest. He discovered innovations that made him world famous in the scientific and beekeeping circle. He's been described as the father of modern apiculture. In 1838, he understood bee space, and he devised movable bee comb a full 14 years before Langstroth in Philadelphia in 1852. So in North America, Langstroth gets all the credit, but history shows Dzierzon was 14 years ahead of it. And then in 1845, he did experiments in crossbreeding. He was crossbreeding light-colored Italian honeybees with dark-colored German bees. And he recognized that while the queen bees and the female workers were the products of fertilization, drones developed from unfertilized eggs, and that process called parthenogenesis. So he's the father of parthenogenesis. He figured out fertilized eggs versus unfertilized eggs, what comes from them, form of asexual reproduction, figured out that diets of the immature bees when they're in the larval stage, egg and larval stage, contributed to their subsequent role. And his results caused a revolution in bee crossbreeding and likely influenced Gregor Mendel's pioneering genetic work on peas. So Dzierzon, he's the guy. So parthenogenesis, how does this work in honeybees? So today we know bee sex is determined by a single locus called the sex locus or position on one of the honeybee's 16 chromosomes. So humans have 23, honeybees have 16. And so on one of those chromosomes, there's a locus, and that determines the sex of the bee. So on the left, there's an unfertilized egg. It's got one sex allele, so it's only got one chromosome, not a pair of chromosomes. And that's the sex allele. And so what you see on the left there is going to turn into a drone. On the right, you see fertilized eggs. And so, the group on the right, you see a red and a yellow, a red and a green, a red and a blue. The red comes from the queen, the mother. The yellow, the green, the blue, etc., come from the various drones that she's mated with, and those become females. And each of those eggs would become sisters, sister worker bees. The pair on the left there, the pair of red, that would be a diploid drone. So kind of unusual. It's not going to become an adult and usually get carried out by workers. Practically speaking, it gets complicated. It gets complicated really quickly. The previous chart just showed the sex allele portion on the chromosome, but there's lots of different other alleles on the chromosomes. And so in this example, there's a queen in the upper left, mates with, let's say, 10 drones shown on the right. The colors kind of in their thorax are the sex allele. The colors on their abdomen are the various other traits. And so very quickly, this queen mated with 10 drones can produce, let's say, 4 other queens, but they're all different. And then lots of other worker bees, right? So it gets complicated really quickly in practice. But one fun fact for any math geeks in the audience, drone ancestry turns out to be the Fibonacci sequence. And so when you're starting from the bottom of this pyramid, you know, a drone has one mother and no father. So it's an unfertilized egg from the queen. But that queen has 2 parents, a mother and a father, a queen and a drone. And so on, you work your way up the table and you get the Fibonacci series, 1, 1, 2, 3, 5, 8 per team. So how cool is that? That bees in nature are the Fibonacci sequence. Anyways, I thought that was really cool. So all the math geeks, you can smile the rest of this presentation knowing that nature really is cool. So why is genetic diversity, well, how does it show up? How do you know? How can you see it as a beekeeper? So colonies headed by queens who've mated with lots of unrelated haploid drones produce solid brood patterns. You know, lots of all those, all that worker brood, they're all sisters, all half sisters, right? But if the queen mates with one or more of her brothers, you get the bottom picture, and those related. Those alleles are identical to hers because they're her drones. And then in the colonies that have a large portion of those diploid drones, there's shot brood. You get brood of different ages scattered all around. It can look like disease, but it can also be like this. Now, in natural conditions, the frequency of diploid drones, before the destruction by workers, before the workers haul them out, in a colony is about 5%. So in natural conditions, normal mating, you get about 5% of this. But the frequency can be much higher in cases where there's not, where there's inbreeding, and that interferes with colony performance. So practically speaking, you see a pattern like this, you rule out all the diseases, you probably don't have a great queen, and you should replace the queen. All right, mating, how does it happen? Physically, practically speaking, what happens in the DCA? So as we said, virgin queen flies to an area where there's hundreds, thousands of unrelated, sometimes related, but hopefully unrelated drones, and they're waiting. The drones pursue the queen. You know, they have those big eyes, big flight muscles. They see the queen, they pursue the queen. And sometimes there's so many drones, they'll form a visible comet, what looks like a comet, chasing after the queen. And so researchers, queen spotters, beekeepers, sometimes you'll see this comet and you can then find the queen at the head of the comet. Several of them will mate with her in mid-flight, one after the other. The 3 pictures at the top here illustrate the mating sequence. So first on the left, the drone mounts the queen, grabs it with his feet, inserts his endophallus, contracts his abdominal muscles in one big sudden pulse, pushes almost his entire hemolymph. So the equivalent to blood or similar to blood, you can think of it as blood, the soft stuff inside his body, pushes the entire hemolymph into his endophallus, and now he's paralyzed. His mobilized body is pushed back as the queen now contracts her sting chamber, and the drone's endophallus is ripped out of his body and remains attached to the queen. The drone's body falls backwards. The drone dies very quickly with his abdomen burst in this fashion. And this whole event, the series, the first, the middle, and the right pictures on the top, this whole event occurs very quickly, 2 to 5 seconds. Now, during this mating flight, the queen loses altitude as the drone mounts her, right? So it's big, heavier. He's not flapping his wings anymore. So she starts to lose altitude. Observers have noted the drone comet going up and down as it pursues the queen. Subsequent drones mount the queen, remove the previous drone's endophallus or mating sign before mating with the queen. And then the sketch at the bottom in yellow shows the reproductive anatomy of the drone on the left, queen on the right. And let's say of the 100 million or so sperm that get deposited by a dozen or more males in the queen's oviducts, a mixture of only 5 million or 5 to 10 million is stored permanently in the queen's spermatothea. The remaining 90% get discarded as she flies home on her mating flight. Okay, so that's it. That's how it works. Here's a picture just to show a bee returning to the hive with the mating sign still blocking the sting chamber. The worker bees will remove that mating sign in a day or two. You know, after 3 to 5 days, that queen will start laying. So if you ever see a queen like this, she has just returned from her mating flight. All right, so I just mentioned kind of the prevailing wisdom. A dozen or so drones will mate with the queen. Turns out queens are even more hyperpolyandrous than previously thought. Hyperpolyandrous, what does that big word mean? It means they really mate with a lot of partners. So previously, you know, I told you it was 10 to 12, 15 or so. Research is showing it's really more, it could be more like 50 plus. Molecular paternity tests were developed in the 1980s. Data from a 1984 study, the second bar there. 130 colonies were in the study from around the world, and they analyzed average number. They measured molecular testing, something called patrolines, about 12. And they said, oh, okay, about 12. Then fast forward to 2012, a study from 80 queens, commercial bee breeders in the US. They redid the test, well, 17, okay, it's a little higher. But more recently in 2018, David Tarpey and his researchers have shown that it's really more like 54. They identified some royal subfamilies. So groundbreaking work, right? And now as an aside, you say to yourself, I told you earlier, this guy Zirzan, who did crossbreeding with bees in 1848, he raised his reputation of a scientist because he figured out how drones were built, right? But one of the things he also put forward, and he's now a rock star in the scientific community, was an idea, an erroneous idea, that queens only mated with one drone. And that was accepted and taught for more than 100 years, more than 100 years. So I only put that data point, the 1848 data point on this chart to remind us all that, you know, there's things we know, science tells us things, we believe them, good people tell us those things and we believe them, but then later on, new methods new facts, new research can change our view. And this chart illustrates this with the number of drones that mate with queens. Okay, so polyandry, why is that a good thing? Is it a good thing? Well, Delaplane at University of Georgia did some recent research and found it does actually have significant benefits for us as beekeepers. And what he found is that queens that mated with more drones, he did a set of 15, 30, and 60 drones, produce two things we like. They produce more brood and you get fewer mites. So you can think of polyandry as kind of like reverse or anti-selection, right? It's the opposite of selective breeding, but it achieves some very desirable results. All right, so how do we know what we know? Well, who are the pioneers? Who led the way? First off, I'd say Roger Morse and Norman Gary at Cornell in the 1960s. They discovered that drones fly high and that they're attracted to queens or their pheromones. And then the Ruttner brothers, Friedrich and Hans, in Austria and Germany, they identified the distinct locations where drones gathered, and they gave us the name drone congregation area. And then the married couple, Gudrun and Nicholas Koeniger, who studied under Friedrich Ruttner, they detailed the honeybee mating behaviors. So just want to do a shout out to pioneers that kind of led the way and help us understand what we know today. What are some of the research technologies that they used? Well, the technology has also progressed over time, along with our understanding. So on the left, you get helium balloons, and what the Ruttners and Gary Morse, those guys did, they'd fly a helium balloon with a string, and attached to the string would be either a queen in a cage or a bottle of queen pheromone. And then they'd watch the drones fly after it. More recently, you get these UAVs, or unmanned aerial vehicles, not drones, but I'll call them UAVs. You put a digital camera on it, and you attach a string to a caged queen or a pheromone, and now you get to watch it in real time with good imagery and see what the drones do. But in both of those cases, the left and the middle, you're really having drones chase a caged queen or a pheromone. You don't know what happens in nature, right? You don't know what happens in nature. And so on the right, researchers have recently begun to deploy radar with transponders attached to the bees. You see the transponder kind of stuck on the thorax of the back of this bee. And you can track drones and queens in flight. You can track them in their natural environment. Well, how natural is it for a drone to be flying around with a transponder stuck on his back, right? But that's new technology, right? So all of this, we kind of know. The Koenigers with Jamie Ellis and Larry Connor wrote this book called Mating Biology of Honeybees. So if you're really into this, here's the book to get. Tom Seeley did the foreword. He thinks it's pretty awesome. So if you really want to deep dive into this topic, here's a good book that'll get you started. Okay, so let me kind of summarize what we've been talking about. Back to this original concept I showed at the beginning. I'm going to fill in some specifics. So this picture shows one way that we conceptualize a DCA and its key attributes, right? So starting on the right, researchers have reported it's shaped like an inverted cone, maybe 100 to 200 meters in diameter at the top, extending from 5 to 40 meters above the ground. And it contains a large number of drones, some estimates as high as 10,000 at times, concentrated at the lower levels, but some up at the high levels. And the drones are in convoluted looping flights, right? Looking for virgin queens. And drones leave the hive and fly at about 25 meters from the hive to this drone congregation area. And they'll make 6 flights of about 25 minutes each. And after every flight, they got to return to the hive to refuel. So that's why their limit is 25 minutes, right? So they can only carry enough carbohydrates to fly for 25 minutes. And then they got to go get some honey, take a break. And the drones usually fly between 2 and 5 p.m. So maybe later in southern latitudes and only on warm sunny days. Now the queens fly at a lower altitude, maybe 8 meters. They'll make hopefully potentially to avoid their brothers in flight, right? And they take their mating flights in a narrower window of time, perhaps to ensure that there's drones out and about. Research has also shown, kind of below the green squiggly line there, that drones prefer DCAs closer to their colonies, while queens will go farther, right? Queens will go 2 to 5 kilometers, drones, half a kilometer to 2 kilometers. And this is thought to be evolutionary behavior, with queens seeking more unrelated drones, while the drones prefer close DCAs, so to maximize their time flying over the target, so to say, before they have to refuel. Okay, so that's, I think, the data on the model that summarizes the basic thinking today. So here's a picture. What are the attractive traits? Researchers have identified a couple different traits that make it attractive locations. One is one of the earliest hypothesized traits is this thing called depletion of the horizon. And that's where light intensity is maximized, presumably to aid drones in visually identifying virgin queens. Another trait is downsloping terrain, so especially south facing. A third trait is maybe along a landmark or a windbreak, such as a tree line. And finally, some researchers have suggested that DCAs form and grow in the presence of queen pheromone, right? Or drone pheromone. One interesting thing is DCAs have been known to exist year after year at the same location, right? Indicating that there's maybe a genetic component that helps drones and queens get to the DCA, but maybe also these physical traits that we just talked about. But how do drones and queens find their way? So some research is uncovering the existence of these flyways, these paths on the yellow and green, blue on the left and the right, kind of aerial paths that drones consistently take to and from DCAs. Don't know a lot about this, but maybe more research needs to be done. Just here's a picture of the depletion of the horizon. So you can see kind of you're up in the Alps. This is from the Gudruns. If you're looking down a valley, the light gets better. And if you're a drone, you want to fly there because you're likely to be able to spot a queen flying by against that light background. Okay. So we've covered a lot of ground so far talking about DCAs, but what are some things that researchers, beekeepers don't know about DCAs? Well, here's 5 that I uncovered just in the research. One is persistence. So why do some DCA locations persist year to year? For example, at Cornell, right outside the biology department where Tom Seeley's worked, there's a big tree, and that tree over the lawn, they say there's a drone congregation area and gets fired up by late May in New York, year after year after year. Locating, how do drones and queens find the DCA? We talked about that, but how do they do that, year after, if the DCA is the same year after year, how do queens and drones find it year after year? Exclusivity. Why don't drones pursue queens outside of the DCA? So researchers have observed drones breaking off their pursuit of the queen if the queen ventures outside of the DCA area. Now, why is that? Why would nature cause an animal to do that? Why does that make big mystery? Consistency. Why do the vast majority of drones always from one colony always fly to the same DCA? But some drones will fly to different DCAs, right? So we know that. Researchers did a study and they painted all the drones different colors in the colony and watched where they flew, and you found out all the red painted drones went here and the yellow ones. So why is that, right? Why is there consistency? And finally, and I think this is the coolest thing, subspecies differences. So different subspecies have been measured to mate at different heights in the DCA. So, for example, Italian drones and queens tend to mate at lower altitudes. Carniolans will tend to mate at higher altitudes in the same DCA. Why is that? And if there's that kind of a difference, are there other differences between subspecies, like time of day? Do the Carniolans get up and get working earlier, the Italians a little later? You don't know, right? Why are there these mysteries? And then as I was putting this talk together for my Master Beekeeper program, you know, I'm getting ready to give the talk. I've got it all written. Like a week before the presentation, I do one final Google Scholar search, and there's new research off the
Paul, I can't hear you right now.
Yeah, I think we lost the audio.
Paul, did you realize we can't hear you right now?
Yeah, hold on a second.
Oh, no, we can. We got your back.
Got me back. I don't know if it's my headset or,
You ran out of batteries.
yeah, it didn't beep in my ear, so I don't know. Let's give it one more time. Shout if it cuts out again. So this is a great picture, one of several from their research, where they mapped actual flight paths. Here's one of the outputs. It shows the drone flights from colony number 1 in blue through an open field along a tree line, through 3 previously identified DCAs lettered A, B, and C. And they exhibited a looping flight behavior. And so, you know, this is like flight 520. You can imagine this technology being applied and what it showed. But here's the real key thing. When you put all of their findings together, this new research really challenged previous hypotheses. So that picture that I showed you earlier, well, here's kind of a new picture, because all those previous hypotheses were based on the use of caged queens or pheromone lures as attractants, and now they're measuring actual queens. And so this radar tracking showed that DCAs maybe are cylindrical, not conical in shape. They're smaller, maybe 30 to 50 meters in diameter. There's maybe 2 orders of magnitude fewer drones, less than 100 at any one time. And the drones stay for much shorter periods of time, maybe a minute versus 10 minutes or more, before moving on to other DCAs, which was previously thought uncommon. And they use these persistent flyways, big, wide, 30 to 50 meter wide flyways. And so new mysteries emerge, right? Such as the size and the shape of the DCA, the number of drones in the DCA, time they spend there. So many of the reasons and ways in which honeybees use DCAs continue to remain mysterious to us as beekeepers. All right, practical application. Drone saturation. You know, listen, if you're doing a queen mating yard and you want your queens to be robustly mated, put them in the center of a 2 to 5 kilometer circle, and on that circle put your drone yards, or put your honey production colonies that have drones in them, right? A lot of commercial beekeepers do this, queen breeders do this. It's just a practical application, makes sense from all the research that we've shown. Ideal queen mating yard. Clearly you want it to be within flying distance of the drone colonies. You want it near a pollen source. You want landmarks, clean water, free of pests. So if you're going to do queen mating, do drone saturation. A lot of people ask me, especially this time of year, when can I make a walkaway split? When can I make walkaway splits? Well, you know, let's go to the beekeeper math, perfectly articulated by Michael Bush in his book, Practical Beekeeper. And we've learned that drones take longer to develop than queens, and now we know why. Drones take 12 days longer. So what we want is a sufficient number of drones that are sexually mature, flying to DCAs when that first virgin queen from our walkaway split comes flying by. So we have to align those dates, right? So it's 26 days for the queen to go on a mating flight, plus or minus 5, 38 days. That's a 12-day difference. So practically speaking, how's that work? So let's just say on April 10th, you're doing an inspection. Maybe, okay, you're in Canada, May 10th. April 10th, you go in there and you got large sections of capped drone cells, right? So you may not see any drones yet, but you know they're coming because you see all these capped drone cells. So now it's safe to go ahead and make that walkaway spring split. You've given those drones that 12-day head start. The bee math says that on or about, fast forward May 8th, that queen 26 days later is on her mating flight, and 38 days after April 10th, those drones are flying, right? So that's a good example of making a walkaway split, and when it's safe to do that, knowing that you'll have enough drones. Okay, so there you go. I hope you've enjoyed this talk. I hope you've learned something. Drones are fun. Obviously, they're important. If you have questions, happy to take them now.
There we go.
It did cut out. Michelle, any questions in the room there?
There's one in the chat. Do you want to open that up?
Yes.
That's my question. So my question was, since there is this knowledge that drones in a specific colony prefer a specific drone congregation area, is there any theories on, like, is there a dance that they advertise a drone congregation area?
Do drones do waggle dances?
That is a great
Any sort.
question. Yeah, that is a great question. And there's been no reported no reports of a dance unique by drones or for drones for a DCA. And Tom Seeley's done a lot of work identifying the various dances that bees do, both to find food sources, and then for swarms, how swarms communicate, where the swarm's going to go. Nothing on drones, but that is a great question, and I would like to ask him about that, but I haven't seen anything like that. So I think, I would say right now it's, I guess the research would say drones somehow genetically know where to go.
So for now, we just hypothesize that it's just genetics and that's it, right?
Correct. No special dance. No first drone found one and tells all the other drones.
All right.
Great question.
There's a couple of
What
questions.
happens when drones can't fly due to poor weather? Yeah, like we've had. So, the drones don't fly, the queens don't fly either. And everything gets, set back, right? Or, you get a queen who will go out, but the drones haven't. And, that queen doesn't get properly mated. I've seen that. I've read that in the literature, people reporting, oh, it's been very rainy and now my queens aren't producing right. Right. So I think, all it takes is one queen to go out on a rainy day and there aren't a lot of drones, and you'll have a problem.
In DCAs, are there multiple queens that enter the same DCA at one time, or do they kind of avoid each other?
Another great question. There's nothing in the literature that I encountered that said queens attempt to avoid each other. Queens are all looking on their mating flight for, I think, the first DCA. They're looking for, a DCA and maybe multiple DCAs. The one thing I didn't touch on in the talk, the research shows, queens will, some queens will do one mating flight, some queens will do 2, 3, 4 mating flights. Of the queens that do 2 to 3 to 4 mating flights, they will do them on multiple days, right? And so what causes a queen to say, okay, I've had enough, one mating flight's it for me, versus, hey, I'm going back out? They measured, is it the amount of sperm? Is it the number of drones? And none of that correlated with why queens decide to go, to say, I'm not going to do any more mating flights after one, or I'm going to do multiple. So I don't know, that is not a direct answer to your question, but related, hopefully.
Is there any research, like I saw there that you had, like in the image, there was a drone with a transmitter, right? Like, is there research done on the queen side to track them going through those DCAs?
Yes, that that same research, they put a transponder on the queen as well. I just showed a picture of it on a drone. So they put transponders on the queen and on multiple drones.
So my question is, to be more specific, was it just one queen in that study, or like did they get a chance to do, let's say, 3 queens with 3 transponders at the same time to see where, like, how they avoid / compete for drones and stuff?
They did multiple studies, multiple colonies, so multiple queens.
Okay.
I have let me just flick here to so here's the references, and the one I'm looking for is Woodgate. So number 18 here is the source for that. You can find it pretty quickly and read about it. Woodgate and radar tracking, Google will take you right to their research.
Awesome.
So Paul, a lot of beekeepers, some beekeepers aren't aware or don't think about that when they buy the foundation, the plastic printed foundation, this is worker size. And so if you have a box filled with these frames, it slows down the drone cells because it's not as easy. But the minute you leave any extra space accidentally, or if you use drone traps, that, as I do for cultural, all of a sudden the percentage of drones in a colony can go from 1 or 2% really quickly up to like 20 or 25%. A lot of people don't realize that left to their own devices, the colonies would make a lot more drones than we let them by giving them the pre-printed foundation. Because you raise queens, are you more likely to allow your colonies to have higher drone populations? Because I know when we find them, sometimes we think, ugh, drones, and scrape it off and feed it to the chickens kind of thing.
Right. Yeah, so you're right. Imprinted worker cell size inhibits drone making. If you don't maintain proper bee space, they will fill it up with typically drone comb. If you leave the colony crowded, they will fill the area between boxes with drone comb. I did an experiment for the last 2 years, left basically 2 or 3 honey supers on each box, on each colony. So I'd have 4 or sometimes 5 boxes, and I overwintered in a big space. And typical, I guess the conventional wisdom is no, condense them down into a smaller space, just the brood chamber. But for various reasons, I had to do that. And when I came back in spring, what I found is that the space between each box. So at the bottom of each frame, they basically they filled that space between the bottom bar of the one frame and the top bar of the frame below it. They filled it with comb, and it was all drone comb. So those frames were all glued together. So they'll make drone comb. What do I do for queens? I just let my production colonies do what they would want to do. I don't really tear down drone comb. I've used drone frames, the green ones, in the past.
You can also get drone comb by putting a medium frame in a deep box, and then they'll build drone from the bottom. And then that's kind of really easy to get rid of it, because you should just slice it off. And then
that is one of the best things to do. And I first learned that trick doing bad beekeeping.
That's how I learned it too.
And that's how you learn. But that is a great, simple way to, if you want to build a lot of drone comb. And look, we didn't talk about mites. It's kind of like, how many presentations do you hear that don't talk about Varroa mites? But one of the quick ways to test for Varroa is to just open up a bunch of drone cells, that are capped drone cells. And if you see mites, if you can see mites on the pupa, the drone pupa, you got mites. If you open up 10 or 15 drone cells and don't see any mites, you might be doing okay. But if you open up 10 or 15 and you see 1 or 2 mites, you got mites.
Did Jana have one more question there? Where do drone congregation areas occur in a city?
Oh, great question. Where do they occur in a city? So I think, just go back to that chart that I showed earlier. Depletion of the horizon. So where, between maybe two tall buildings where there's light channeled between them, where there's some visual markers, parks, any of those same attributes. And remember, from your colony in the city, that queen's going to go, what I say, up to 2 kilometers. They've been shown on occasion. Sealy went to some British Isle, I think it was British, maybe Nova Scotia, and put bees on an island where there were no other native bees and measured how far queens would go to mate. And he had one go like 8 miles. But I think the conventional wisdom, it's more like 2 to 5 kilometers. So there's in a big city, you have a colony in the center of the city. There's a drone congregation area somewhere in the city.
This is I don't know what a walkaway split is.
Oh, a walkaway split? Yeah. What is a walkaway split? So just real quick, let's say you have a colony coming out of winter in 2 deep boxes. And you open it up, you can't find the queen, but there's open brood in both the top and the bottom box. Take one box and set it over on another bottom board. And if the queen's in that one, great. The mother colony will make a queen. And if the queen's in the bottom box and you set the new box over on the other side, they'll make a queen. So a walkaway split is you just take 2 boxes and split them apart. And all of the things being equal, the one that doesn't have the queen will make a queen.
One that doesn't have the queen will make an emergency cell, like an emergency cell.
They will select a day 4 egg. So an egg that is just hatched into the larva stage, and start feeding it royal jelly. They'll say and they'll make multiple emergency queen cells.
Paul Kelly spoke about emergency queen cells at our November meeting. Spoke about walkaway splits. And so if you go onto the UTBA YouTube channel, you can look at our November meeting and you will know everything you want to know about walkaway splits, including why Paul Kelly never recommends them.
Oh,
Yeah. So we're all converted now. We all don't do walkaway splits now. We do queen cells or maiden queens. We don't do.
Listen, if you have a good source, a good reliable source of queen cells, yes, take the queen cells every day. But if you have, as one beekeeper I know has 100 colonies, and he hopes to overwinter 100. The first thing he does in spring is walk away and make 200. And he's like several beekeepers. He's cheap, doesn't want to spend money. So he just does walk away. He doesn't want to buy queens, doesn't want to buy cells, doesn't have time. He's a winemaker. And so he takes 100, makes 200, and away he goes, makes honey.
There's beer time after this meeting. We can chit chat all about splits at the pub tonight.
I can help you with good quality queen cells. Just let me know. I also have a question. So you mentioned David Tarpey's research about like the diversity of like higher number of drones basically identified based on the genetics of the sperm, I guess, right?
Yeah.
Is that something that can be like, is that commercially available, or he just did that for research at some point?
Are you talking about this chart by Tarpey or this one by Delaplane?
The previous one.
Yeah. Again, I'll let you read the third source citation there, Withrow. with Tarpey in 2018. And it's a little bit of a complex paper. They get into defining these cryptic royal subfamilies. And, you know, I'll take them on their word that it's different, but it sounds to me like it's splitting hairs. So in other words, are the drones really genetically different? Like from a different queen? Or are they from somehow different but related queens, right? So I'd have to go back, before I say any more, I have to go back and reread that paper.
All right, all right.
Yeah. But I think as a beekeeper, you know, for our purposes, I think this is the research that really, you know, wowed me. You get, you know, better brood, you know, more square centimeters of brood per 100 bees, and you get fewer mites because you've got more genetics. And this paper was very good. If you think about it, a queen that is mated with 60 drones versus 15. The queen that's mated with 60, some of those 60 drones may have very hygienic behaviors, okay, in their DNA. So now, of all her worker bees that she's cranking out, maybe 10% have that very hygienic behavior. And that's all it takes to keep your mite population under control. Right? So not all the workers have VSH or ankle biters or whatever, you know, you want to describe them as. But if some do, it's enough. It's enough. Okay. All right. Well, look, this has been really fun. Great questions. I have some follow-up work to do to get my own questions answered. But hopefully you've learned about drones and have a new respect when you open up your colony. You see a drone.
We don't just want to like cut them off and throw them away.
All right. Thank you.
Thanks very much.
Thank you very much. This has been very, very interesting.
I have 2 housekeeping items that I'd like to tell everybody. You will all be thrilled to find out that we are having 2 field days this summer. Yeah, so June 11th, we will have a field day with Ellen and Cumberland Bees, and we will organize it. It will be a field day and barbecue social. And in July, on July 8th, Tom Nolan with Hivetown Honey will entertain us at his Scarborough Apiary. Lynn is in Brampton, at his Scarborough Apiary for another field day, learning opportunities, and barbecue and social. So I will announce that, and if people are going to have a difficult time getting to it, we can consider, you know, chartering buses or creating a carpool system. So just wanted to throw that in there. That'll be coming out in email soon.
Tom, is that at Bavna's place in Scarborough?
Yes, yes. I've had some high losses in that yard this year, but my other yards are doing fine. So basically, I'll rebuild that yard. So that'll be a good sort of I think some good discussions around that. Basically, how do you recover from some losses, and what's it look like by July when you're starting with some splits and some nukes?
Any clue on what happened there? Like,
yeah, I would chalk it up to beekeeper error. Pretty busy last year, so I got kind of behind. I split pretty aggressively. And the colonies that, when I make my nukes, I tend to make my nukes stronger and leave my sort of parent colonies the weaker. So my splits that I moved to my out yards, they tend to fare okay. So it was my home yard. So I think it was a combination of probably splitting a little later than I should have. And then when I was late into the season, that's when I got busy. My feeding was a little bit later, so it was just an accumulation of sort of what I would call maybe a little too aggressive beekeeping. But again, keep in mind, when I say too aggressive beekeeping, as you know, when you're doing it full time and you have the time, you can be more aggressive, but you got to be on top of everything. I think I got a little too aggressive and I didn't have time because, I travel a fair bit during beekeeping season. So, yeah, and I think I talked about this in our last meeting. When you grow pretty fast from being a hobbyist where you're doing things like mixing syrup in your kitchen, and all of a sudden you've got 100 colonies and you're no longer mixing syrup in your kitchen. You're either, mixing it yourself or buying it pre-made. And even the feeding, feeding 100 colonies as opposed to feeding 2 yards, which are 20, 40 colonies. And we'll talk about that at the field day. Some of the things I plan to sort of do this year is what I call fine tune my efficiencies, building a feed pump, mixing syrup in higher volumes, the infrastructure stuff that I was lacking that really slowed me down and made the sort of tasks a little harder.
Which feeders are you using?
I use pail feeders, right? And again,
5 gallons, 3 gallons?
4-liter pails. 4-gallon pails is typically what I do, right? But again, I have a toad on my truck. I was gravity feeding.
Yeah.
So when you park your truck on a bit of an angle and you're trying to fill a lot of pails and you're waiting for that pail to fill and just all those things that slow you down, right? So this year it's buy some money, buy a pump, speed up the process. For all you folks who are just backyard beekeepers who only have a couple of colonies, you won't have these issues yet, but you might. You might, because we all started somewhere. Yeah. So I basically, Alan, I would chalk it up to my own sort of errors and management decisions. Yeah, I know a lot of times beekeepers want to look outside themselves. I tend to look in.
Yeah. We had a yard that was historically larger number of losses, but that's how we fixed it. And the cause was lack of time.
Yeah.
Like we had too many colonies, and then we were just a number. We have a great survival rate for this year.
I think our friend in Manitoba, Ian Stepler, he has a good line he says every now and again. He said, the bees will tell you how many colonies you can manage. He tends to hover around 1,500. And he says every time he tries to go above 1,500, he tends to have problems. So he says, I think the bees are telling me this is my max capacity.
Yeah. There's all sort of things that you find when you have more than one yard. Like this spring, we had to move the hives behind me outside, and then some of the yards were not accessible because of the melting snow, and we couldn't drive in. So yeah, there's all sort of things that pop up randomly, right?
Yeah.
Well, random for this year, because next year we learned our lesson. We know where to go, which yards, can be driven in, but that's, surprises.
Yeah. But I think even on a hobby level, when you have, 1 or 2 or 3 hives in your backyard, I mean, I think we learn by just doing. We make mistakes along the way, and hopefully we don't do ourselves in, but, I've made every beginner mistake there is. I'm still making them. Truly enjoyed that presentation tonight.
Yeah, it was good. Really good. It was really great.
Fantastic.
Yeah.
All right, shall we conclude here?
Yeah, sure. The honey's great.
We're all going out for beer. And we're gonna chit chat and socialize. Right now, we are tasting these amazing honeys that Renee has brought back. I can see from Ireland and from Sicily. That's as far as I've gone on it. There's like 10 bottles down there. So maybe next time you will think of joining us in person so that you can partake in the little snacks and beer.
And I will appreciate if for the summer bee art visit days, you will bring those delicious honeys with you.
We definitely will do a honey tasting at each field day as well as a barbecue.
We could do like a honey exchange
Yeah, for sure.
thingy.
I haven't. Orange, very good.
Thanks very much. Wish you guys can
All
all
right.
join us.
Thank you. Have a good night.
Good night. Thanks, everyone.